Hello. If we haven't met before, my name is Miss Nichols, and this is the first of a series of flipped instruction videos that can walk you through some of the important content in our freshman 9th grade year physics class at WHS. Before you get going, hopefully you have a notebook in front of you, and hopefully you have the volume of your video on. Subtitles are available if that kind of thing helps you. And a pencil, obviously, to take notes with. I would really advise you to use some sort of structured note-taking style if you're comfortable with that. For example, if you've learned Cornell notes where you divide your page in half and you write your notes on one side and your thoughts on the other, that would be a really good model to use. But in general, this is a good time to start establishing good habits as far as notes. So make sure the volume is on, you're comfortable, you've got all the supplies that you need. Every video is going to start with an essential question. So for this video, the essential question is, what are variables, units, and operators, and how do I identify and use them? So that would be a good first thing to write on your paper to think about as we move through this. And at the end of the video, I'm going to ask you to spend a little bit of time thinking about that essential question and trying to process it, and I will reward you for all your efforts with a Calvin and Hobbes comic usually to wrap up. So that's kind of the structure of this, and let's get going. So you may have heard the word variable used in a prior science class. For the purposes of this class, we are going to define a variable as something that has a scientifically measurable, so you have to be able to take data about it, numerical value, which means you have to be able to have a number associated with it, and that number has to be changing over time, or at least able to change over time. So if I wanted to give you some examples and not examples so that you can really start processing what variables are, something that is not a variable is a dozen. A dozen is a number, so it has a numeric value. It would meet that criteria, but it never changes. Dozens are always 12, so you can't say that's something that's going to change, therefore it's not a variable. Another not variable is your brother. And I know that sounds silly, but over the course of the year, this is something that comes up a lot. We have questions, word problems that are about people or animals or dogs, and people are constantly trying to make those things the variables, but those aren't changing in physics. I don't know how to measure your brother. He doesn't have a number that is associated with it, and he's not changing over time. So basically doesn't meet any of those criteria for a variable. Another one that sort of comes up often is something like how good a piece of pizza is. And the problem with this is not that you couldn't assign a number value with it. I couldn't say, like, on a scale of 1 to 10, what's your opinion? But the problem is that it's an opinion. It's not scientifically measurable. There's no tool that would recreate reliable data on how good a pizza is. So even though it could be a number and it could change over time, it's not scientifically measurable, so we wouldn't consider that variable. So what are some examples of variables? Well, height would be a great example of a variable. It's scientifically measurable. I'd use a meter stick. It's a number, and it's going to potentially be changing as time passes. The speed of a car, again, I could measure that using the speedometer of the vehicle. It would have a number, 25 miles an hour, and it could change over time. There's a graph there shown of like a car trip and how the speed of the car changes over time. Another thing that could be a variable would be the amount of money that's in your wallet. It's measurable, you can count it up, it has a number value, and obviously that changes over time, up and down as you put money in and take money out. So those are some examples of variables in this class. We're going to be spending most of our time dealing with these kinds of interesting values and try to avoid mixing them up with not variables. So there's obviously a lot of variables in the world, but there are 6 extra special variables known as the fundamental variables. These are special variables because they can't be broken apart or turned into anything else, and because by combining these variables in different ways, physicists can actually explain the behavior of almost everything around us, which is pretty cool. So I'm going to introduce you to the fundamental variables, and as we move through the year, you'll find these variables keep coming up over and over again as we seek to kind of describe the way the world works and make predictions about what's going to happen next. The first fundamental variable is time. Obviously measurable, changes, fits all of our criteria for variables, and you probably realize that's a very important one in terms of describing the way the world works. Distance, which is how far apart things are, is another fundamental variable. Mass and energy go together, and we'll learn about that later in this unit, but that describes how much stuff is inside of an object. something called the charge, which is a subatomic particle known as an electron or a proton, and we'll talk about those a lot in our electricity units. And then the last two are ones we won't cover in this class. They're known as color and spin, and they're actually not what you traditionally think of when you're actually thinking of something with color. They're properties of tiniest little quarks that are inside of atoms, that are inside of protons. And I only bring them up just in the interest of completion, and also in the interest of sort of exposing you to some big, exciting new physics. If you love this class and end up wanting to take more physics, then we'll talk about the importance of those two fundamental variables. But for now, these are the four that you should really be familiar with and that we'll use over the course of the year. Every variable and everything we measure in physics class will include something known as the unit. A number's unit is the descriptor that gives that variable meaning and size in the physical world, and it can also help you figure out what the heck the variable is if you don't know what you're really talking about. So for example, if you read this sentence, I'm going to give you 6, hopefully the first question you're asking is 6 of what? And that of what is the units of that number 6. Maybe I was going to give you 6 Hi-Chews, which is my favorite candy, and in a typical year I'd be handing them out left and right. I wish I could give you one virtually, but here we are. So 6 Hi-Chews, that'd be awesome. You'd be like, sure, I'll take it. Of course, that's 6 candies. The other option, maybe I'm thinking I'm going to give you 6 bags of dog poop, and that would probably be something that you would rather I didn't do. And so this is the importance of the units, right? The difference between the candies and the bags of poop. It tells you how big the thing is, and it tells you what the stuff is. So units are going to be really critical. And if I ever see numbers without units, my big question will be, is that bag of poop? What are we talking about here? Because the units are critical in physics. So let's spend a minute talking about the specific variables that we're going to reference a lot in this first unit of the year. Every time we have a variable through the whole year, usually the variables will have a name, which is that variable, and then they'll also have a symbol, which is kind of like a shortcut or a faster way to write that variable. And then there'll be a whole range of units that can be associated with any given variable. So for this unit, the first variable is time. And time will be represented as a lowercase t if we ever use it in an equation, or you just want to write it quicker than writing the whole word time. Lowercase t works as well. There's a wide range of units for time. We've got seconds, hours, and minutes, and eons, and all sorts of other ones that you can imagine. And I'll come back to what that yellow one is in just a few minutes. The second variable is mass, and mass has the symbol lowercase m. Some units that are commonly used for mass are kilograms if you are anywhere else in the world, and pounds if you happen to be here in the United States. The third variable that we're going to be using a lot in this unit is energy, which is represented by a capital E symbol. And you may not have heard the word joules before, or maybe you have in a science class, but I'm certain you've seen the word calorie before. Of course, every time you look at the back of a bag of chips, it talks about calories, which is measuring the amount of energy that is stored up in that chip. The units that I wrote in yellow there, the seconds, kilograms, and joules, are special. They're known as the SI unit. And the reason those are important is because scientists everywhere in the world have agreed that we'll understand each other better if we use the same common units. So everywhere in the country, scientists use those units, even though common folks here in the United States use pounds. It's actually caused a few problems. About 25 years ago, NASA crashed a $125 million Mars rover into the surface of Mars because someone used pounds in America, and some British contractors, of course, used kilograms. So it's one of those things that's really important. It'd be nice if we were all on the same page, but scientists try to use the yellow unit, so we'll be using those mostly in this class. Another idea I want to introduce before we get too far into the year is something known as a mathematical operator. Mathematical operators are like little shortcuts that we put on variables that tell you to do a little bit of math with that variable before you use it. Some familiar ones, plus sign or a square root, or you've got a greater than or less than sign. Those are ones you're probably familiar with, but there's a couple that we use all the time in physics that I want to introduce you to. So the first new operator that we're going to be using all the time is known as delta. And the word delta means change in. So anytime you see a delta in front of the variable, it means that the value of that variable is actually changing. It's going up or down. It's not staying the same. And delta means we don't care about what the value of the variable is. We care about how much it changed from its initial value to its final value. So if you had a dog that was running at 12 o'clock and it stopped running at 12:45, the time would be 12 or 12:45. But if I asked you to find delta t, that would be how much time has changed from the beginning to the end. Delta t for this example would be 45 minutes. So you should note that they're all different things. If you see the delta, you can't just put the regular old time in there or you're going to get the wrong answer. So whenever you see a delta in physics, make sure that you're thinking about what has changed and how much is that variable changing. One note about this, if you have a variable that's staying the same, the delta t is, or the delta whatever is going to be 0. And delta values can be negative. If you have something that goes down, it could be negative. So if I'm talking about the money in my wallet, if I don't spend anything, delta money is the same all day, or 0. If I gain money, delta money would be positive. If I give away money, delta money would be negative. So delta can be positive, negative, or 0. The second new operator I want you guys to be familiar with is known as sigma. And sigma is written as it's shown on the board. It's kind of looks like a funky E. It is the Greek letter S, actually. The Greek S is the way it's written, and you may have seen that before in different Greek organizations. But in any case, when you see the word sigma before a variable, it means, in math and science, it means take the sum or add up all of the values of that variable. So if, for example, me and 3 friends, or you or 4 friends each had $10, and I was like, well, what's the sigma money? The sigma would be the total. It would be 10 plus 10 plus 10 plus 10. Sigma money would be $40. So it's pretty straightforward. It just means add up all the values of that variable. All right, we made it through the first slideshow. The last step before you close up your notebook is to revisit that essential question. What are the variables, units, and operators that we talked about in this lecture? And how do you identify and use them? This would be great to put in your own words. If you wanted to condense the entire lecture into just a few sentences, what would those sentences say? So please do create this summary statement for yourself in your notes. There's been a lot of research that's shown you retain and understand things a lot better when you summarize it at the end. And I'll ask you to pause the video right now and do that. And when you're done pausing, I've got a Calvin and Hobbes comic just as a little bit of a reward for getting through. Thanks very much for watching. All right, if you unpause and watch the end, Calvin is one of my absolute favorite characters, and it's amazing to me how often what Calvin experiences is relevant to physics. So hopefully you'll enjoy.